What are your thoughts? I'd be curious. You're a really
Yeah.
good person to ask, which is Roger Penrose's work on consciousness, saying that there is some with axons and so on. There might be some biological places where quantum mechanics can come into play, and through that create consciousness somehow.
Yeah. Okay. Well,
Are you
uh,
familiar with his work at
of
all?
course, I read Penrose's books as a teenager. They had a huge impact on me. 5 or 6 years ago, I had the privilege to actually talk these things over with Penrose, at some length at a conference in Minnesota. And, he is, an amazing personality. I admire the fact that he was even raising such audacious questions at all. But to answer your question, I think the first thing we need to get clear on is that he is not merely saying that quantum mechanics is relevant to consciousness,
Hmm.
right? That would be like that would be tame compared to what he is saying, right? He is saying that even quantum mechanics is not good enough, right? If supposing, for example, that the brain were a quantum computer, right, that's still a computer.
Yeah,
In fact, a quantum computer can be simulated by an ordinary
that's right.
computer. It might merely need exponentially more time in order to do so, right? So that's simply not good enough for him. Okay, so what he wants is for the brain to be a quantum gravitational computer, or he wants the brain to be exploiting as yet unknown laws of quantum gravity. Okay, which would be uncomputable in Turing's
Uncomputable. That's the
sense.
key point.
Okay, yes, yes. That would be literally uncomputable. And I've asked him, to clarify this, but uncomputable, even if you had an oracle for the halting problem, or as high up as you want to go in the sort of the usual hierarchy of uncomputability. He wants to go beyond all of that. Okay, so just to be clear, like if we're keeping count of how many speculations, there's probably like at least 5 or 6 of them, right?
Yeah.
There's first of all that there is some quantum gravity theory that would involve this kind of uncomputability, right? Most people who study quantum gravity would not agree with that. They would say that what we've learned, what little we know about quantum gravity from this ADS-CFT correspondence, for example, has been very much consistent with the broad idea of nature being computable, right? Um,
So
but all right,
that's
but supposing that he's right about that, then what most physicists would say is that whatever new phenomena there are in quantum gravity, they might be relevant at the singularities of black holes. They might be relevant at the Big Bang. Uh, they are plainly not relevant to something like the brain, that is operating at ordinary temperatures,
right.
with ordinary chemistry, and the physics underlying the brain. They would say that we have, the fundamental physics of the brain. They would say that we've pretty much completely known for generations now, right? Because quantum field theory lets us sort of parameterize our ignorance, right? I mean, Sean Carroll has made this case, and in great detail, right? That sort of whatever new effects are coming from quantum gravity, they are sort of screened off by quantum field theory, right? And this brings us to the whole idea of effective theories, right? But that, like, we have, in the standard model of elementary particles, right? We have a quantum field theory that seems totally adequate for all of the terrestrial phenomena, right? The only things that it doesn't, explain are, well, first of all, the details of gravity. If you were to probe it, like at extremes of curvature, or at like incredibly small distances, it doesn't explain dark matter. It doesn't explain black hole singularities, right? But these are all very exotic things, very far removed from our life on Earth.
Yeah.
Right. So for Penrose to be right, he needs, these phenomena to somehow affect the brain. He needs the brain to contain antenna that are sensitive to
To
this
black holes.
to this as yet unknown physics, right?
Yeah.
And then he needs a modification of quantum mechanics. Okay, so he needs quantum mechanics to actually be wrong. Okay, he needs what he wants is what he calls an objective reduction mechanism, or an objective collapse. So this is the idea that once quantum states get large enough, then they somehow spontaneously collapse, right? That and this is an idea that lots of people have explored. There's something called the GRW proposal that tries to say something along those lines. And these are theories that actually make testable predictions, right? Which is a nice feature that they have. But the very fact that they're testable may mean that in the in the coming decades, we may well be able to test these theories and show that they're wrong, right? We may be able to test some of Penrose's ideas, if not his ideas about consciousness, but at least his ideas about an objective collapse of quantum states. Right. And people have actually, like Dick Baumeister, have actually been working to try to do these experiments. They haven't been able to do it yet to test Penrose's proposal. Okay. But Penrose would need more than just an objective collapse of quantum states, which would already be the biggest development in physics for a century since quantum mechanics itself. Okay. He would need for consciousness to somehow be able to influence the direction of the collapse so that it wouldn't be completely random, but that, your dispositions would somehow influence the quantum state to collapse more likely this way or that way. Okay. Finally, Penrose, says that all of this has to be true because of an argument that he makes based on Girdle's incompleteness theorem. Okay.
Right.
Now, like I would say the overwhelming majority of computer scientists and mathematicians who have thought about this, I don't think that Girdle's incompleteness theorem can do what he needs it to do here, right? I don't think that argument is sound, okay? But that is sort of the tower that you have to ascend to if you're going to go where Penrose goes.
And the intuition he uses with the incompleteness theorem is that basically that there's important stuff that's not computable. Is that where he takes
it's not. It's not just that, because everyone agrees that there are problems that are uncomputable, right? That's a mathematical theorem, right? But what Penrose wants to say is that for example, there are statements, given any formal system, for doing math, right? There will be true statements of arithmetic that formal system, if it's adequate for math at all, if it's consistent and so on, will not be able to prove. A famous example being the statement that system itself is consistent, right?
Right.
No, good formal system can actually prove its own consistency. That can only be done from a stronger formal system, which then can't prove its own consistency, and so on forever. Okay, that's Girdle's theorem. But now, why is that relevant to consciousness, right? The idea that it might have something to do with consciousness is an old one. Girdle himself apparently thought that it did.
Oh, really? That's interesting.
Lucas thought so, I think, in the 60s. And Penrose is really just, sort of updating what they and others had said. The idea that Girdle's theorem could have something to do with consciousness was, in 1950, when Alan Turing wrote his article about the Turing test. He already, was writing about that as like an old and well-known idea, and as one that as a wrong one that he wanted to dispense with. Right?
Yeah.
Okay, but the basic problem with this idea is, Penrose wants to say that, and all of his predecessors here, want to say that, even though, this given formal system cannot prove its own consistency, we as humans, sort of looking at it from the outside, can just somehow see its consistency, right? And the rejoinder to that, from the very beginning has been, well, can we really?
Yeah.
Maybe he, Penrose, can, but, can the rest of us?
Yeah.
Right. I noticed that it is perfectly plausible to imagine a computer that could say, it would not be limited to working within a single formal system, right? They could say, I am now going to adopt the hypothesis that my formal system is consistent, right? And I'm now going to see what can be done from that stronger vantage point, and so on. And, and I'm going to add new axioms to my system. Totally plausible. There's absolutely, Girdle's theorem has nothing to say against an AI that could repeatedly add new axioms. All it says is that there is no absolute guarantee that when the AI adds new axioms that it will always be right.
Right.
Okay. And, and that's, of course, the point that Penrose pounces on. But the reply is obvious. And, it's one that Alan Turing made 70 years ago. Namely, we don't have an absolute guarantee that we're right when we add a new axiom.
Right.
We never have, and plausibly, we never will.